Okay, in this video we're going to look at how we can use trigonometry to find missing angles in right angle triangles. Now before we do that, we're going to look at the inverse trig function. So the inverse trig functions are sine to the minus 1, cos to the minus 1 and tan to the minus 1. And it's easy to remember that they are the inverse trig functions because they're on the same button on your calculator. So sine to the minus 1, how you get it on your calculator is shift and sine, cos to the minus 1, shift and cos, tan to the minus 1, shift and tan. So we're going to look at how we solve these equations. Now I like to think about mathematics as being nothing more than order and opposite. So if you know what something is doing and then what its opposite is, then you can solve any equation. So here we want to find what theta is on its own. So to get theta on its own, we have to do the opposite. Of sine. So the opposite of sine, we have just been told, is the inverse of sine. So sine to the minus 1 of 1/2 is what we want to do. Now I'm going to just put up a wee calculator here and show you how we actually put that in on our calculators. So you can see the calculator here. How we do this, you can just about make out probably that sine to the minus 1 is on the sine shift function on the sine button. So hit shift and then sine, and that's what comes up. Now because it's a fraction, I'm going to use my fraction button, and I'm going to put 1 in my top square, top box, and the bottom one. So go down to it and hit 2, and you have to go right, just close the bracket, just good practice, close the bracket. Sometimes it'll work without, sometimes it won't, so just put it in and press equals, and that you can see that gives you 30, and the answer is 30 degrees. Okay, very easy. For part B, same idea. Theta is going to be equal to the opposite of cos is cos to the minus 1 of 1/2. I'll just show you in the calculator how we can do that. So I think we've got sine to the minus 1 of 1/2 still in. We have. So if you go put, you could have just started again, blanked this out and gone back, but I'll just show you how you can use your calculator to edit it. So if I go back out of here and delete, so I've deleted my sine to the minus 1 and do shift and the cos. There's my cos to the minus 1 of 1/2. So if I press equals, I should get my answer, which should be 60, and you can see it is 60 degrees. Okay, we're not going to go through all of these. But just to show you here how we do them all, we're not going to do them all, showing you all in the calculator, but theta is equal to tan to the minus 1 of 1/3, and if you did that in your calculator, you'll get 18.4 degrees. Oh, I've got the degree sign on the 60, and that was the 1 dp. This one, sine to the minus 1, theta is going to be equal to sine to the minus 1 of 1. And if you do sine to the minus 1 of 1, you'll get 90 degrees. Here, theta is going to be equal to tan to the minus 1 of 0.124. And if you do that, you'll get 7.1 degrees. And again, that was to 1 dp. And this one, theta is going to be equal to cos to the minus 1 of 0. And if you do that in your calculator, let's just see what we get. If you do that in a calculator, cos to the minus 1 of 0, you get cos to the minus 1 of 0, you get 90 degrees. Okay, now we're on to what we actually want to do in this video, is show us how we use this, use SOHCAHTOA to find missing angles in right angle triangles. Now the first thing you've got to do is label your triangle as we had done before. So this is just your h, your hypotenuse. The 4 is your opposite. So then you write down your SOHCAHTOA again, and you think which letters do they involve. So remember, this is sine is O and H, cos is NH, tan is O and A. So sine was the one that involved the O and H. So write down your formula. We had sine theta is equal to O over H, and then we just fill in what we know. Now in this example, it's not theta, the angle is X, and my opposite is 4. And my hypotenuse is 10. So we can do this on our calculator now because sine to the minus 1 of 4 over 10. So look back up in the video and see how we did this on our calculator. And if you do that on your calculator, sine to the minus 1 of 4 over 10 gives me 23.6 degrees, and that's to 1 decimal place. Okay, same idea in the next video, in the next example. All we're going to do is label our triangle. This 11 is clearly hypotenuse. This is beside, so this is the adjacent. So again, write down your formula. write down your memory tool, I should say. We've got SOHCAHTOA. So we've got, it's going to be cos this time because we've got a and h. So write down cos theta is equal to a over h. And then in this case, that's cos of theta is equal to 3 over 11. That means theta is equal to cos to the minus 1 of 3 over 11. And whatever that works out to be, do that in your calculator. And I have got 74.2 degrees to 1 decimal place. Okay, same idea. We'll just write down our memory aid, SOHCAHTOA, and then label our triangle. Right, so this is a wee bit trickier, so let's just take a wee bit of time to this one. You've got your, this one is opposite your y, so this 5 is your O, and then this one is beside, so this is your adjacent. So it's O and A, so it's going to be tan, so write down your formula. Tan theta is equal to O over A, opposite over adjacent, and then fill in what you know. Tan of y is equal to 5 over 3, which means y is equal to tan to the minus 1 of 5 over 3. And if you do that on your calculator, you will get 59. And it asks us, very careful here, it asks us to go to 2dp, so 59.04 degrees to 2 decimal places. Okay, last example says, in the triangle ABC, angle B is 90 degrees, BC is 12, AB is 16. Find angle A and angle C. Okay, best thing for you to do here, it's just a rough right angle triangle you're drawing. Label the right angle first. So the right angle was B. And then your A and your C can go anywhere. I put the A on the horizontal and then the C on the vertical here. And then read the question again. It says BC is 12 centimeters, so that's 12. And as well give the units as well, 12 centimeters. AB is 16 centimeters, and mark on your right angle triangle. It says find the angle at A. So there's my angle at A. I'm going to call it theta. I'll find it first, and then I can find, hopefully I can find the angle C fairly easily as well. So label this from this, my 12 would be my opposite, and the 16 would be the adjacent A. So again, let's just write it out. We've written it out every time, and by the time you've done this all, you will have it in your head forever, hopefully. So SOHCAHTOA. So we're going to be using tan to do this one. So tan theta is equal to opposite over adjacent. And then in this one, we've got tan theta is equal to 12 over 16. And then to get your theta, you'll do tan to the minus 1 of 12 over 16. And if you do that, what you will get is 36.8699 ... a whole pile of things. So if I've gone to what, 4 decimal places there, I would just say, therefore, your angle A is equal to, and generally we'd be going to 1 decimal place. So we're just going to say the angle A is equal to 36.9 degrees to 1 dp. Okay, now the reason I've put this in is because I'm going to use this angle theta to find my other angle. So that's why I've used this. The easy way to find my other angle, I think it was called angle C. It was angle C is going to be equal to 180 minus 90 minus your angle A. So in this case, it's going to be 180 minus 90 minus your angle A, and I'm using the longer version of A, the more precise version of A, so 36.8699. And when I did that, I got my angle C to be 53.1301. And then I just give my final, so therefore C is equal to 53.1 degrees to 1 decimal place. Now, if I'd used the 36.9 in this particular one, it would have worked out exactly the same, but you don't know that. So I would just always use, if you're using, going to use my A in the later part of the question, so use a lot more decimal places just to be sure you don't get the answer wrong. Tidy it up for the person marking it and just say your answer, angle A is equal to 36.9 degrees and angle C is equal to 53.1 0.1 degrees, and they were both to 1 dp. Okay, you now know how to find missing sides and missing angles in right angle triangles using SOHCAHTOA, your trigonometry.